Hi, good morning, guys. I apologize. I am out at a cousin's funeral today. So I have this video for you to keep up with on the notes. Okay. So we're going to look at polynomial functions. Poly meaning many, and numeral, number. So this is the many number function here. All right. And we're looking at an x to the n. So a is just a number, x is the variable. And n is the number that we have in our series here. All right, so it's just representing a position in the polynomial. All right, so an, where you have the n, that's called the leading coefficient. And I'm not going to write the whole thing out. I will abbreviate that as LC pretty much from this point forward whenever I want to talk about leading coefficients. Okay, so that's the number that is the first in the series of numbers. Then these are lined up in numerical order from greatest to smallest. So this is some number larger than x squared or x squared, x to the third, fourth, fifth, whatever. All right, so on this one where we have examples of polynomials, we're going to talk about what the leading coefficient is, and now the degree is the number of the exponent. So classify each polynomial by its degree, and that is the number that is on the largest value variable exponent. Okay, so on this one we don't see an exponent or we don't see a variable. Well, if I take x and put it to the 0 power, that's equal to 1. Anything to the 0 power is equal to 1. So it's just like not even having that x there. And this doesn't really have a degree. Some people say 0 degree, but we're going to say it is constant. Okay, the leading coefficient here is not really a leading coefficient, right? But it is 4. Okay, now let's look at this one. The variable has a coefficient of 1. So this is first degree. And the leading coefficient is a -5. So that is a negative leading coefficient. Next one is, let's say, second degree, because it has a 2, second degree. It has a 2 up here on the exponent. I'll circle it for you. All right. And the leading coefficient is a positive 12. Understanding whether they're positive or negative is important, which you'll see a little bit later. All right, now let's look at this next example. We have negative x to the third minus x squared plus 8x plus 1. The leading variable up here is 3, right? So that's going to make this third degree. Okay, and I forgot my R in there. Let's put the R back in there. Third degree. And look at our leading coefficient. There's a negative there. Well, that's just -1. So that is a negative leading coefficient. Okay, look at this exponent. This is the 4 up here. So this is to the 4th degree. And if I take a look, my leading coefficient is -3. Okay, let's look at this last one here. My exponent here is 5, so this is to 5th degree. And the leading coefficient is a positive 9. So the positive and negative will play an important role actually in the next page in the notes. So let's take a look at what happens here. We're looking at the parent function we're going to identify. So f of x of a constant, let's just make it 3. F of x of 3 is going to give me a horizontal line. Ooh, that's supposed to be horizontal. With a 0 slope, so it's just 3. It is not the same as linear. It is constant. It doesn't change. If it is linear, so it's going to be a straight line. right, with a slope other than 0 and undefined. So let's say this is f of x, and let's say it's equal to, let's go at 1/2 x on this one. Actually, I'm supposed to do the parent function, so let's just call it x. Okay, so it's linear. We've seen that. You saw that in 9th grade. Quadratic, you saw that in 9th grade. And this is primarily what we've been working on at the beginning of the year. So f of x is equal to x squared. So that's going to have a shape like this. Now, you need to memorize all these shapes and parent functions. So if that was a shape of a u, it's a 2. Right? If it's 1, it's just a linear straight line. Let's take a look at cubic. Now this is just x to the 3rd power. Well, x to the 3rd power is going to look like a parabola broken in half with the left side turned down and the right side still in place. So it's kind of like that S-turn swervy thing there. That is cubic. Let's go to the next page. Quartic. So this is f of x to the 4th power. If it's to the 4th power, it's going to kind of go something like this. Parent function is actually a little lower. It goes lower for the parent function. But it looks something like that. Almost like a W. Right? Almost like a W. So if you look at this, this kind of looks like a 4 with a fancy thing on it. All right. Quintic. This is to the 5th power. So if it is to the 5th power, it's going to go something like and off this way. Okay, so that is to the 5th power. Hopefully you noticed the pattern for the number of turns. You can check this out. So the number of turns is related also to the power. So there's the exponent minus 1 will tell you the number of turns. So to the 5th power, you can see it has 4 turns. To the 4th power, you can see it makes 3 turns or 3 changes in direction. Okay, so now we're going to talk about in behavior patterns. Okay, I am actually going to jump down to, well, actually I'm going to jump to a new page. We'll come back to this. Let's jump to a new page, easiest way. So if we have a coordinate plane and we're looking at a polynomial, and let's say the polynomial, let's just do a simple quadratic curve. Ooh, that's not going to give it to me. Simple quadratic curve. The thing we look at within behavior are the arrows on the end. I really don't care what happens in between. None of this really matters when we're talking about in behavior. So we're looking at what the arrows are doing, whether they're going to infinity or if they're at negative infinity, right? Ooh, and then with in behavior, we're really just talking about the y in many respects, right? Because we're going to say as it goes right. So positive infinity on the x is right, negative is left. And then if we're going to positive infinity on y, that means it's going up. And if it's going to negative infinity, that means it's going down. So if I look at this function, okay, this function tells me that I have a positive leading coefficient because this is where the positive leading coefficients would be. And yes, it makes sense. The negative leading coefficient is over here. And that's strictly on the right-hand side. So this leading coefficient tells me that I have a positive leading coefficient. This arrow tells me I have a positive leading coefficient. And then if they're both going in the same direction, that means that we have an even degree. That's what that tells me, that I have an even degree. So it's a leading coefficient that is positive with an even degree. Well, that tells me as x goes to the right, that's going to be positive infinity. My y values, since it is a positive leading coefficient that's going up, that means the y values on the right-hand side, because that's positive infinity, are going up. And since it is an even function, that tells me that the right side, which is negative infinity, or excuse me, the left side, which is negative infinity, this is my right here, that tells me my left side is also going to be going up. So even is the same. So if they're even, okay, right and left in behaviors, I'm just going to say EB for in behaviors, are the same. Okay. So if it's facing down, it would be negative. The leading coefficient would be negative, and down would give me a curve kind of like this, right? So if this is my arrow here, this is my arrow here, we know that this one on the right-hand side, x is going to positive infinity, y to y on that side is going to negative infinity. And since it is even, because they're going to be the same, that means my left-hand side, x going to negative infinity, is going to be the same as my right-hand side, y is going to negative infinity. Okay? So let's pick it up in the next video. We're going to talk about odd in behavior. Okay.